Hello, in this session we look at the extraction of zinc and lead by the reduction method. Welcome. Now, zinc and lead are less reactive metals. For this reason, they are suitably extractable by the reduction method in which a blast furnace is involved. The main procedure is that of roasting, which is synonymous with oxidation of the ore. When the ore is oxidized, all impurities are removed. The main impurity is sulfur, which forms sulfur dioxide. Now, once the ore has been oxidized, we get the metal oxide, either zinc oxide or lead oxide. We proceed to the next level of reduction. And during the reduction, we can either use carbon or carbon monoxide as the need is found suitable. When we use carbon, the temperatures for reduction process need to be high because carbon is in solid state. So we use around 1000 degrees Celsius. And in that process, the extract is obtained as a molten product. When, however, we reduce the oxide of the metal extract by using carbon 2 oxide, the temperatures are relatively lower at approximately 700 to less than 1000 degrees Celsius. The product henceforth is in solid state. So let's take a look. So number one, zinc is extracted from zinc blende, and zinc blende is zinc 1, zinc 2 sulfide. So when you take zinc 2 sulfide and you roast it, it means you're burning it in excess air, temperatures above 1000 degrees Celsius. The net result is that we form zinc oxide and sulfur dioxide as a waste product. Once zinc oxide is formed, we take it to the next level where we reduce it rapidly by carbon into zinc extract and carbon monoxide as the waste byproduct. The temperatures here are 1000 plus. Next, we could reduce zinc oxide by simply using carbon monoxide, and the net result is that we still form zinc, but this time round in solid state. The byproduct is carbon dioxide. The same principle is applied for the extraction of lead, and lead has an ore referred to as galena. Galena is lead 2 sulfide. Now, when you take lead 2 sulfide and roast it, which means you burn it in excess air, you readily obtain lead 2 oxide and sulfur dioxide waste byproduct. Next, you will take the lead 2 oxide formed and reduce it by carbon at 1000 degrees Celsius, and that will give us molten lead and carbon monoxide as a byproduct. When you have decide to reduce the oxide of lead by using carbon monoxide as the reducing agent, the temperatures will be 700 to less than 1000, and the product will be in solid state. The waste byproduct will be CO2 gas. Now, this shows clearly that the extraction of zinc and lead are identical. The difference is just the nature of the ore. What then are the properties of each of these metals? Let's begin with zinc. So for zinc, we find that zinc is a blue metal. It's a blue metal. It is malleable. It is a poor conductor of both heat and electricity, and it is insoluble in water. Now, for this reason, zinc is suitably used as one, a cell agent, and mainly as a cathode in dry cell lichlanche. Number two, even though it's a poor conductor, it relatively conducts, that's why it's used as an electrode. Number two, when zinc combines with copper, it forms brass, used for manufacturing cooking plates and utensils. When zinc combines with copper and tin, it forms the German silver. Good. So those are the main applications of zinc. Number 2, what are the properties of lead? Number 1, lead is a gray metal. 2, it is brittle. It has a high melting point and boiling point, and it is highly insoluble. Now, lead is used in motor engines to manufacture what is known as the engine blocks. Number 2, it is added in fuel to form the engine anti-knock additive. The engine anti-knock additive in leaded fuels. Number 3, lead is used as a blocking agent in nuclear reactors because it can stop all potential nuclear radiations. The main one stoppable is the gamma ray, and the gamma ray is of high intensity, so it can block any other. So in summary, we've said that zinc is used in manufacture of dry cells as a cathode, manufacture of brass and German silver. It is blue metal, it's malleable, poor conductor but insoluble. Lead, we have said, is gray metal, it's brittle, high melting and boiling point, insoluble. Manufacture engine blocks, manufacture engine anti-knock additive, that's why it's added into fuels, and it is used in the nuclear reactor as a stopping agent to radiations. So that has been the analysis of the extraction of zinc and lead from their respective ores, zinc blende and galena. Thank you.